name is Miriam Unterlass. I'm a research group leader at the Technical University of Vienna, both in the Institute of Materials Chemistry and the Institute of Applied Synthetic Chemistry. And my team and I work on developing novel and environmentally friendly syntheses for high-performance materials. We are specifically interested in generating materials that show outstanding performance, such as very high thermal stability, high resistance to chemicals, and additional properties such as eventually conductivity via environmentally friendly syntheses or processes. And we do so by using high temperature water. So in a typical hydrothermal experiment, we would take any kind of vessel and we fill that with water, with the amount of water that we need, and the corresponding starting compounds. And then we close that thing, so you can pretty much imagine that like a pressure cooker actually, and we heat the whole vessel up. So in the vessel we generate high temperature water of temperatures, we need at least above 150 degrees C, but typically say 180, 200 upwards. And under these conditions, water becomes quite different from what all of us know at room temperature. The materials that we are working on are all supposed to be interesting for applications in the area of alternative green energies. Specifically, we are trying to contribute to materials for conducting ions. So, for instance, in lithium-ion batteries or also in fuel cells. And we are also interested in making materials for photovoltaic applications, so solar cells basically. I'm still startled by the fact that we can really make so many different materials. Now we are at a point where we can make small organic molecules, pigments and dyes, where we can generate so-called molecular sieves. That is really like a pasta sieve, if you will, so like a mesh with channels on a molecular size scale. And we can make hybrid materials, so combine inorganic and organic components. The role of the FWF is huge for our project. Our research goal in that project is really very much in the area of fundamental research. So we have an application in mind. We would like to contribute to materials for alternative energies. Yet, to make these, we need so much understanding of how this works, where the limits are, what can we tune, what can we do, and that is not possible on such a scale without the appropriate funding that allows you to really explore in an open and free-minded fashion. We are the only ones that make organic materials in hot water, so to learn these methods, you have to be here, and my co-workers are learning these methods at the only place that does them. So I'm thinking this is a great skill set for any kind of future job in this field. Plus, our project is really very international, so all my co-workers profit from this international collaborative approach.